You guys can see my screen?
Yes, sir.
Yes,
Okay.
sir.
Okay. So up to expert systems, I hope it's clear. And those who are having a lack of attendance, just keep in track, because here I am having, just inform your friends also, because calculation thing, I have to write a code for the calculation, because I have a good amount of Excel sheets generated for every class. So I have to merge them, and I have to use the CSV to generate which email was login for how long. So it is means anytime you come, and if it is a normal attendance record, I could open a attendance sheet and I could tell you, said you have attended this many class. But for here checking one by one, it's troublesome. So I'll actually directly merge those things and finally do it once, because otherwise every time doing it is actually a hell lot of a job. So I'll not do it again and again. So I'll do it at the end of the course only. So those who are falling short of attendance, just at least log in, because here it is totally automated. Means your Excel sheet is being generated, which email is being logged in for how long. Okay. So I'll be merging the document at the end only, because it is just wastage of time every time merging just to say how many hours you have attended. So you keep track of your own thing. I'll be doing it, and in the end of say the class, maybe January or something, I'll be doing that thing. Okay, just inform your friends to keep track, because later on I cannot change, because here along with the Excel sheet generated email wise, login time, log off time is there. So based on that duration I'll be taking, and date wise logins I'll be merging directly. Okay. So just inform your friends to be online, as it is online. Wherever you are, you can log in from there. Okay. Otherwise, you can plan for offline also, but offline means you have to be on time, all of you, because common course means electrical is late or electronics is late. I am having trouble with the first year students, because their class is 12 to 1. Somebody comes at 12, somebody comes at 12, 13, 15. So three departments merging together is actually a problem in offline itself. So in online, five departments is a problem. Anyway, so otherwise I have to stick to the time, and close in and close out well in time. So still you see at 10:20 also people are logging in. And I was logged in from 10. I think Madhurima had joined at 10, so she knows. Anyway, so starting with the fuzzy logic. So this is the another application of AI. Many of you, mainly the electrical guys, are say using that a lot. Even statistics guys use this a lot. Others I don't know, but my department, this IT students, they are taking fuzzy logic as a elective. So this time they are studying this as a separate course. And as Tasdik said and others, many of them have taken up fuzzy logic. Even statistics guys have taken a fuzzy logic. So as the name is fuzzy, so most of you know that the logic is fuzzy. So mainly here this is bringing into the fact this the fuzzy things that we human reasoning do. So this was given by Jade, and I had the opportunity to meet this great person in one of the conferences in way back in 2015, if I'm not wrong, in uh, Pisa, Italy. So I had the opportunity to listen to him physically. He was, and even at that age, at that time, I think he was 70 plus or so. So uh, even at that age, he was a very good teacher, and that I was very lucky to have listened to him, and say physically for one session. Anyway, so this fuzzy, now he is no more. Just before the COVID, he passed away. Uh, anyway, so fuzzy logic systems produce these kind of response like we do, which are incomplete or ambiguous, or I can say they are plastic kind of response. Plastic, this term I am coining, because nowadays hardware based these things are called plastic hardware. Means where you have the flexibility between true and false. Neither it is a fully true or neither it is fully false kind of thing. So instead of a normal digital values of 0 and 1 or yes and no, we humans are say, okay, this is somewhat okay. I'll not say that okay. If somebody asks you, is this good? Now, is this good? We humans have many things based on which we don't want to say a direct yes or direct no. If we say direct yes, बोलेगा अरे इसने बोला था इसीलिए मैं लिया था, ये तो अभी बोल रहा है ये खराब है. So to play safe or give diplomatic answers is a normal human way. So this fuzzy logic actually does human reasoning, and here it imitates our decision makings, where we say sometimes say near yes or near no, or say neither yes neither no kind of situations. If I just bring into the 5 phases, and you can have more than 5 phases also. You can have numbering systems, and based on that you can have the gradings. uh, so the conventional logic that we and as well as our computers understand is binary, that is 0 1, true false kind of thing. So here we are trying to produce something which is near to that, based on that. So this is by Lofty Jade, as I told. And unlike normal computers, here we are having a range of possibilities between this. So instead of a normal yes and a normal no, we have certainly yes, possibly yes, cannot say, possibly no, certainly no. So this is just 5. You can have more than 5 also. So just in case you divide into this, instead of normal binary system, here you have a 5 system. But that also, here also, it is not a pure demarcation. You can put say numbers like 0, 0.2, 0.4, 0.4, 0.6, 0.8, or say something like 0.1, 0.2, 0.3, 0.4, 0.5 kind of percentages we can put based on that. So you can increase more also. Here it is easy way out to keep it within 5. So I'll be explaining the whole thing keeping it in 5. Others, anyone who has done a fuzzy logic course have done more than 5? Anyone? Tasdik, you had done?
No, sir.
Okay. So this is a common way, means here we are just, instead of putting 0 and 1, we put numbers. Say the last one, say I can put 0, the first one I can put 1, but in between I can use something like 0.3 and 0.5 and say 0.7 for possibly yes, 0.7 for possibly no, 0.3, and cannot say as 0.5. Okay. So electronics guys, I think you know what happens in diodes or NPN transistors, or even the electrical guys who have studied digital, you know that up, if I have a 0 to 5 volt range, what is the range of 0? What is the voltage of 0? Anybody can tell? Standard voltage range of 0 and standard voltage range of 1. Anybody? If you have say in a digital circuit, if you have 0 to 5 volt, you normally do 0 means 0, 5 volt means 1. But normally there is a range for 0 based on the fan in and fan out of the digital logic. Electrical electronics guys should be able to tell. Electrical electronics guys, nobody? You should be knowing this. Others have not studied that in the circuit level, so they should not be telling me, but at least electrical electronics guys should know.
I think it will be 0.8. Maybe,
Yes,
sir. I
yes,
need
yes. No, no, no.
idea.
Correct, correct. That's correct. 0 to 0.8 is 0. And what about plus 1?
It will
Electronic?
be between 4 to 4.5, sir, or 4.5 to
No, no.
5.5.
2.5 also is taken, but it is device to device it changes. For positive, they have kept it more because normally when it is 0, it is not a problem. 0 or zero point 0.8, it's 0. But when it is positive, then maybe instead of one device, one gate, you may have multiple gates. So to power the multiple gates, you need sometimes there is large fan in or fan out kind of thing. So for those kind of things, it is 3.5, or in earlier days it was 2.5 also, means From 2.5 to 5, all were considered as 1. Means voltage is coming means it is 1. Voltage is not coming is 0 kind of thing. So, but electronics guys, you should be knowing this. Okay, Tasdik is from electrical, I guess. So, others you should be knowing this. Anyway, nowadays the things have changed. Nowadays you have CMOS, so slight changes are there. But anyway, uh, you should be keeping this into your account. Next, coming to the implementation part. So if you come to the implementation part, what you have is fuzzy logic works on different levels of input, where here when you are implementing, say whether it is small microcontrollers, a network set of computers, workstation based control, and any other things, there what you do, this possibly yes, certainly yes, then possibly no, certainly no, these things are actually converted instead of 0 and 1. That's why I was giving the example of 0 to 5 volt. Here instead of 0 to 5 volt, you may have say 0 to 1 also can be demarcated as 0, 0.3, 0.5, 0.7 and 1 kind of thing. So a lot of commercial products like washing machines and other things, they are using fuzzy logic. So many consumer based products, they are working based on that. And there may be accurate reasoning may not be there, but to some extent acceptable reasonings are done via this fuzzy logic. And because why you cannot say accurate reasoning, because here you are taking a human reasoning, and which is neither direct 0 or neither direct 1, so it may be in between, which is coming up to the result. So based on that, you are having this kind of outputs. So you have a lot of uncertainty coming into picture. The system architecture, if you see, first there is a fuzzification module. So in this fuzzification module, what you do is you take into the things voltages which are crisp numbers, and you make the fuzzy sets. So here this if you can have LP, MP, these are large positive, medium positive, then small, then medium negative, and large negative, or the same thing as certainly yes, possibly yes, say, cannot say, the same thing, just demarcated in a different namesake. You don't get confused here. This LP, MP, S, MN and LN is same as your that 5 that I'm saying, means the nomenclature is different, but computer doesn't go by the nomenclature. Computer goes by the values that are coming. So those values that are coming are the fuzzy sets, based on which set of value is there. And you can modify the sets based on, say, let me consider that, okay, up to just like Tasdik said, 0.8, up to 0.8 I'll consider as 0. Then from after 0.8 to say 1.2 I'll consider as medium negative. Then from 1.2 to say maybe 2.7 I'll consider as small. So this kind of voltage ratings you can change, and say this is his program, and I take his program and I make some changes there. Now my fuzzy logic and his fuzzy logic outputs may not be same, because when we converted the fuzzy sets, we from the crisp numbers, we didn't do it in the same algorithm. Our numbers were different. Getting the things that we can do. So sometimes what are there? There are different optimization algorithms which decide on what should be the range of large negative, what should be the range of medium negative, and so on. So there are a lot of bio-inspired algorithms which are there. We try to get accustomed, like those who have been in the campus, you have seen the migratory birds there. So based on these migratory birds also, there are a lot of optimization algorithms. So when the birds are flying, the strongest flies in the center or in the front, and it receives a lot of wind, and after it gets tired, it goes back and rests, and the next strongest one takes over the charge. So whoever is leading the flock, he has to be the strongest, and as they are going for long flights day, so we have algorithms based on that. So based on sparrows, based on ants, we have based on bees, based on this fishes, based on crow. You can look into that. There are different bio-inspired algorithms: ant colony, beehive, fish swarm, then sparrow, something I forgot, crow, something is there. So there are a lot of inspired bio-inspired algorithms which can be used, and they can be used to do the fuzzification module. So they can handle the fuzzification such that means instead of you doing trial and error and giving the numbers, the optimization algorithm will do trial and error and optimize. Then you can use genetic algorithms, you can have genetic programming for that, and a combination of genetic algorithm and genetic programming, which Namanita had asked me, is gene expression programming. So you can have gene expression programming for that, for the different optimization algorithms and other things. So there are whole lot of people working on different areas, different applications. It may be one application somebody is doing on control system, somebody is doing on statistical analysis, somebody is doing on, say, earthquake analysis, somebody may be doing on rainfall analysis. So you can have whole lot of things which can be done here, and somebody may be simply working on consumer electronics, and there in the consumer electronics, what kind of things the system does, and you can keep like that. Even some of the banks have done it, means based on your pattern they will actually modify the things. Anybody I don't know, SBI doesn't have it. Anybody having HDFC account? Anybody having HDFC account here, out of 25, 26 of you? Or have you ever been to a HDFC ATM and withdrawn money? So what is the difference in the HDFC ATMs compared to SBI or any other? Means which may be your original bank. In case you can tell, then I'll means if you have seen that, then I'll tell you. When you insert the card and when you say plan to withdraw money, what does it suggest? No, in the screen, is there any suggestion whenever you insert the card? What suggestion they give? Means based on your spending pattern or based on your withdrawal pattern, you'll be getting a pop-up that means, say, regularly you are withdrawing 5,000 rupees or regularly you are withdrawing 10,000 rupees. You'll be getting a pop-up based on that. And in case you are regularly transferring, means once they get the card, even if it is not from their bank, they can accustom because means once you have inserted the card, they get a idea what means what type of transactions you are doing in your system. So they can get the idea in case your account is connected, means say if you have a loan or not. It may be a car loan, home loan, anything, but they can get the idea. Because how can they get the idea? Based on a regular transaction. Regular transaction means if you have a regular transaction from your account to if you have a regular transaction, say you have a car loan or a home loan or any loan, so always on a particular date you are paying something to the bank, and that will be a fixed amount unless say you want to pay extra. So they can directly extract the amount which you are regularly paying. So that is a financial based system. So if you are inserting your HDFC your any other bank ATM into HDFC bank account, and if you have a loan, they can automatically detect that you have a loan. Okay, and next after 2 days you'll be getting a SMS that we are giving this much interest. You want to say shift your loan or something is there. Okay, so that is what I was talking about. So that they get based on your spending patterns and what. See here, somebody's loan may be of a bike loan of 1,000 rupees per month, and somebody's maybe a home loan of say 20,000 rupees per month. But the main pattern will be same. Getting the idea? So if they analyze one financial year's system, they directly can predict what is your spending pattern. And they will be giving you pop-up, means last few times if in your ATM, whichever ATM you have transacted, so you have taken out 5,000 rupees every time, this time also they will give you option, do you want to take out 5,000 only? It is unlike that you will have to select savings account, click the amount, or say select the amount. So those things is there. That is in the HDFC new ATMs. If anyone who is interested can try. Uh, so here this is the block diagram. So you have a crisp input coming, and here you have the fuzzifier. So the fuzzifier will actually do the fuzzification of these LP, MP, S, MN, LN kind of things, and this fuzzy input set goes to the intelligent systems, and there are some fuzzy set rules. So based on this, the intelligent system will follow the rules and get the fuzzy input and make some decision and give a fuzzy output. Now again, this fuzzy output is not understood by the user. So what you need a reverse process of a defuzzifier, which will be giving you a crisp output. Getting? Clear up to this? This block diagram part?
Yes, sir.
So it is something like what happens is that say if you go outside, there you will be having pepperoni pizza, or this different popular this Mexican and other flavors. But in India, you will see that they are giving paneer tikka and other things which are Indian flavors. So what they are doing is that the crisp output, the normal pizza base and everything is same. Only difference what they are doing, instead of they are using tomatoes and a lot of cheese and other things, and here they are replacing them with paneer tikka, chicken tikka, and those kind of Indian masalas. So what they are doing is that they are keeping the base thing same, but they, based on the country, they are modifying it. So you can have a global eating point, whether it is McD, KFC, and Domino's and Pizza Hut, everywhere. But only difference is that there what they do is that based on the region and other things. So main difference is that here, based on the region and other things, they change. Okay, so that is actually part and parcel. Now Yasha, you are always late. When I'm going to complete, then only you log in, or sometimes you don't log in at all. Anyway, so next you have this different kind of this large negative, and this fuzzification is there based on region wise, input wise. Say your system, whenever you will be using in your home or something, so
Sir,
you have who? Any question? Anybody?
sir,
Yes.
actually there was no network in my number from the today morning, so that's why
Okay.
it took late
Okay.
to log in.
So next, you have this fuzzification that is there. Means you can have one settings for yourself, and I can have another setting for myself. So the fuzzifier and the defuzzifier is the settings kind of things which we can do. The crisp input and crisp output is what any layman understands, and fuzzifier and defuzzifier part is actually up to us how we handle it. So if it is a program, you can you can change based on that. And nowadays what they are doing is that they are putting a lot of optimization algorithms which are handling the fuzzifier and defuzzifier. Okay, clear up to this? Means this fuzzifier whatever settings you give, if it is 5 point or 7 point, whatever the points that you decide, that is done via optimization. Okay, I can say that I'll use 0, I'll use say 0.3, 0.5, and 0.7 and 1 as the 5. But for you, it may be different. You can use, instead of 0.3, you'll say, no. This medium negative, I'll use 0.2. And small, though it is small, I don't want 0.5. I can use 0.6 there. And this medium positive thing, I will not use 0.7, I'll use 0.8. Fine, you can use that. And once you use that, the defuzzifier may be in that way, or it may be that the same fuzzifier and defuzzifier may not be same also. You can have different sets of algorithms or different settings for both of them. Sometimes they will, both of them will be same, and sometimes they will be different. So you can make changes based on that to get best possible results. That is the basic idea, is that you have to get the best possible ideas. And knowledge base is which will be having the if then else kind of thing, and it will be having the rules coming here. The inference engine is what will actually say infer based on this if then else kind of thing. And defuzzification module it will convert the fuzzy set back to what we understand, the crisp output. So the fuzzy membership function, you see, it's 0 and 1. 0 is the false, and say 1 is the true. And in between you have to have this particular, you can have different quantified linguistic terms which will represent, and based on which will change the membership function. So here each element X is mapped between 0 to 1. So it is called the membership value or degree of membership, whatever you want to call. So here what you have, the x-axis and y-axis are two things, where one is the discourse and another is the membership value. So here multiple memberships are there, and if you see that the graph, just let me show you the graph. Yeah, this is the graph. So in most of the, say, systems you'll be having that, like here they've used -10, +10, and in between -5 and +5 and 0. The same thing I told is it can be 5 volt and 0 volt, means instead of +10 it can be 5 volt, instead of -10 it may be 0 volt, or it can be something like in between you can have say, like I said, 0, then you can have 1, then you can and in between 0 and 1 you can have it as 0.3, 0.5, 0.7, and 1 may be maximum. You can change them accordingly because the membership function and the input voltage can be correlated accordingly. So based on that, you can have this ln, mn, s, mp, lp, or it can be certainly yes, possibly yes, can't say, possibly no, and certainly no kind of things. So these are all different nomenclatures of the same thing. Basically what we are doing is, instead of a direct 0 and 1, we are having 5 options. And that same thing you can expand to 7 options, 9 options kind of thing. So it's up to you, or what algorithm or what application you are applying. You have to just correlate that accordingly. So this triangular membership function shapes are the most common, but you can have function shapes like trapezoidal, singleton, Gaussian distribution curves are very popular nowadays, because for instead of this triangular, you'll be having a Gaussian distribution curve, which is a normal distribution. I think electronics guys are more aware, and even statistics guys are more aware of this particular Gaussian distribution. Statistics, Halima was there. Anybody else who want to say, give me some idea of this Gaussian distribution? Who else is there? From this statistics, Malubika is there. So Gaussian distribution is a normal distribution, isn't it?
Yes, sir.
Okay. So what is the means? Why this Gaussian distribution is popular? Can anybody tell me? Why this Gaussian distribution is popular? Statistics students, you should be telling them. Others don't tell, it's okay, but you should be telling. बाकी लोग भूल गया होगा स्टैटिस्टिक्स. हम लोग आईटी वाले तो फर्स्ट सेमेस्टर में प्रोबेबिलिटी और क्या क्या किया था, but statistics guys should be telling me. Gaussian distribution, what is the importance of Gaussian distribution? The bell shape curved. Okay, I leave that to you. Okay. I'll ask that question in the final exam. You prepare for that answer. Why Gaussian distribution is this normal distribution is the importance of that. I'm telling you the question beforehand. Okay, so you prepare the answer accordingly. So because that is important, and all of you means whichever branch you are from, you should be knowing about Gaussian distribution. अगर IIT में होता तो तुम लोगों का सबको Gaussian distribution मालूम ही होना पड़ता है, because relative getting Gaussian distribution के ऊपर ही होता है. वो 90 मिलके भी 100 में 90 मिलके भी B ग्रेड मिल सकता है, और 30 मिलके भी A ग्रेड मिल सकता है, because of that Gaussian distribution. Yeah, normal distribution. Gaussian distribution is itself a normal distribution, isn't it? मालूम है क्या?
Yes, sir.
So you means here in relative grading and
Sir, in Poisson distribution, when n tends to infinity, then Poisson distribution. सर मैं हिंदी में बोलती हूँ, जब n टेंस टू इन्फिनिटी होता है देन पोइसन डिस्ट्रीब्यूशन नॉर्मल डिस्ट्रीब्यूशन के तरह काम करता है, लेकिन पोइसन डिस्ट्रीब्यूशन रेयर केस में यूज होता है, जैसे एरोप्लेन एक्सीडेंट ऐसे मतलब यूज होता है, लेकिन सर नॉर्मल डिस्ट्रीब्यूशन इज मोर पॉपुलर देन पोइसन डिस्ट्रीब्यूशन.
क्यों बोलना है ना, स्टैटिस्टिक्स का आदमी है, तुमको बोलना है ना. व्हाई?
सर व्हाई?
My question was why. That's why I was leaving the question for you guys. एक क्लास में टॉपर एक आदमी हो सकता है, और एकदम सबसे गधा भी एक ही हो सकता है, या दो हो सकता है. मीन्स वट एवर इज द डिस्ट्रीब्यूशन, वो टॉप करने वाला कम होगा और बॉटम वाला भी कम होगा. मैक्सिमम पीपल आर मीडियोकर. अभी अंबानी कम है, the percentage of people who are richest in India is less, and poor का भी एक परसेंटेज है. poor का परसेंटेज नो डाउट ज्यादा है, बट ज्यादा होने से भी इन टर्म्स ऑफ द पॉपुलेशन इफ यू सी, वो परसेंटेज में वो कम ही आएगा. जितना गरीब आदमी है उतना अमीर आदमी भी है. और जो मिडिल क्लास है उसमें ही पूरा हम लोग वो सर्टेनली यस के जगह में, मान लो यू आर टेकिंग सर्टेनली यस एज द रिच पीपल and certainly no as the poor people, and in between you see the middle class. अभी जिसका एनुअल इनकम मान लो के 50 lakhs भी है, he also will say that he is a middle class. वो अपर मिडिल क्लास होगा लेकिन मिडिल क्लास ही है. और जो जिसका 50 lakhs के जगह में 2 lakhs एनुअल इनकम है, वो भी बोलेगा वो मिडिल क्लास है, लेकिन वो लोअर मिडिल क्लास है. इन बिटवीन यू हैव द, so normally what happens is अपर मिडिल क्लास और लोअर मिडिल क्लास या बीच वाला मिडिल क्लास जो भी हो, इंडिया का मोर देन 70% पॉपुलेशन इज कंसीडर्ड टू बी मिडिल क्लास, जो भी हो. गेटिंग? सो वो उधर में भी सेम डिस्ट्रीब्यूशन है. सो देयर इज अ रीजन व्हाई दिस गॉसियन डिस्ट्रीब्यूशन इज यूज्ड. So I am leaving the question to you guys. You find out, because this is not part of the syllabus, but we are using it, so that's why I am asking you. Okay. So anyway, so here the triangle has been used. You can use trapezoidal also. So this is for 5-level fuzzifier. You can have 7-level, 9-level fuzzifier also. So for an example, say for example we have this air cooler, it's an air conditioner here. So you can have this like the commands may be heat, cool, and no change. So heat means you can consider the one becoming heat, and cool means you have to say the temperature will be lower, and no change means whatever it is. So you have a target temperature, and the fuzzy logic system will be there, and there is a room temperature. So the target temperature and room temperature you will compare. If the room temperature is say high, so and the target temperature is lower than the, say my room temperature is how much, say now see, now Shubham is coming. अभी 11 बजे से उधर जाना है, तो वो he is joining now. So you have this room temperature given, and you have a target temperature. So target temperature is like AC में हम लोग set करते हैं ना, से 24 डिग्री या 25 डिग्री set करके हम लोग रख दिया कम. Now if the room temperature is less, the AC will say say heat it up, and if the room temperature is uh, high, then the AC will cool it down. Now the difference is that if I have set 24 degrees centigrade, room is 18 degree means the room has to be heated up. And if I have set 24 degree and the room temperature is say 30 degree, the room has to be cooled down. So here the cooling portion, initially it will be very high and slowly the cooling will reduce, or vice versa. Initially the heating will be more and slowly the heating will go down. So here we can have any fuzzification module which can handle in this way. So if I want to write an algorithm for that, here our voice will be doing the thing. In case we are not having a temperature based thing, we'll say heat, cool, no change kind of thing. We'll say by voice commands, and the system will understand the linguistic variables and linguistic terms, then construct the membership functions accordingly. There will be fuzzification of these commands like heat, cool, and no change. अभी तो Alexa को भी लगा दिया उसमें. And you have the inference engine which will apply some rule based things and will be doing the thing. Now here normally standard is say 24-25 degrees is a standard room temperature or target temperature, but it may be that say one of you likes to have it a bit warm like 28 or 29, जो साउथ से आएगा उसके लिए 28 या 29 will be a target temperature, और जो मान लो कि यूरोप से आएगा उसके लिए 18 डिग्री या 17 degree will be a target temperature. So accordingly what will happen, based on their command the system will change itself. So you don't need to say go, because based on the person the same consumer electronics will be giving different set of outputs. So that's why this fuzzy logic is very important. So when you develop the system, you have to define the linguistic terms. The temperature is just, instead of this possibly yes, certainly yes, and those things, here I'm using the terms very cold, cold, warm, very warm, and hot. So again it is 5 levels, and we can use linguistic terms converted to these instead of using a normal direct temperature giving thing. And you can have this same say negative, medium negative, small, then medium positive, and say positive, just like earlier. So you have the temperatures here correlated with them. So 0, 10, 20, 30, 40 kind of thing. 40 is normally not very popular, but it may be. So 40, though they have kept, but normally will not have a 40 degree. At least in India, we don't prefer to have it at 40 degree. So you construct the membership functions around them, and as in the below diagram, and you can plan accordingly. And as you go ahead, you'll construct the knowledge based rules based on means who is there and how many people are there. If more people will come, you'll change the temperature accordingly, and you can have this. So you see here what is happening. If left side and right side both are very cold, you see the diagonal terms are having no change throughout. You can see the diagonal terms. So whenever this left side room temperature and target temperature both match, you'll have no change. And in between, whether it is cold, so you have to cool it down for very cold, and here you see his side is all cool and his side is all heat. Okay, you can see the diagonal structure, how the temperature will be changing, and that is irrespective of whether it is for the temperature or any other application. You have to do it in a similar way. So we have to have a if then else kind of structure, and we can put a if then means if temperature equal to cold or very cold and target equal to warm, then heat. Otherwise you will be doing it say cool or say no change. You can see the means how we are having this if then else kind of structure or rule here. And finally you'll have the fuzzy values for that, because here our system doesn't understand this cool and heat. It requires some voltage input, and based on that it will be working. So you have a max and mean for the voltages based on which you will be doing. So the max and mean will be correlated with very cold and very hot, and you can have this. So exact value may be anywhere, and you can do corresponding changes, and you can perform the defuzzification and handle the temperature, and you can get the desired response. Getting all of you?
Yes, sir.
So there are various application areas of fuzzy logic: automotive systems, then consumer electronics, as I was telling, then domestic goods, and say environmental control and many things. But main nowadays what they are doing, mainly electrical guys are using lot in energy optimization and other things, control systems. They are using a lot, so that's why it's very popular. And the advantage is that optimization algorithms are being used with that. So coming to the advantages, what you have the mathematical concepts within the fuzzy reasoning, and they are very simple. Means you are correlating our human values with respect to some mathematics, and you can modify them by adding, deleting the rules, and that is the flexibility of the fuzzy system. And the fuzzy logic systems, they can make some distorted, noisy, imprecise kind of things and reconstruct the whole thing. And you can have different solution to complex problems, means via optimization, via say reasoning and decision making also. It's very, so that's why in control system you use fuzzy based control systems a lot. And the disadvantages is that there is no systematic approach. That's why I'm saying, just like as it will, if it will be a systematic approach, then for me it will be good, for you it will be bad. But if it is not a systematic approach, for both of us it will be considerate. Okay, so understandable, uh, because when it is very simple, then it is it is simple. But what happens is that sometimes it goes haywire. If somebody is not using it properly, you can have different problems. And for where you require, so if you have different systems, like where we need very high accuracy, they may not be up to the mark. So that is one of the disadvantages. So now I'll be discussing the search algorithms in the next class. On say next class I have it on Tuesday. Okay, so Tuesday I'll be discussing these search algorithms. So till then, if you have any doubts regarding the fuzzy logic, let me know.